Okay, in this video we will discuss a very important topic, exponential growth. And essentially any new technology, when it first comes out, the sales of the products will usually follow exponential growth. Then later it will flatten out. You got to be careful about that. But our file will be Google Cisco.xlsx. We'll be talking about the growth of Cisco in the 1990s when it was a fairly new company, and the growth of Google in 2006 through 2010. Okay, and we'll also be talking about the concept of a CAGR, or compound annual growth rate. Okay, I always thought a CAGR meant where's the beer. Okay, well, the equation for exponential growth, well, let's start with a straight line. We had y equals a plus bx. And so b is the slope. When x went up by 1, y always went up by b. But a common thing in the scientific world, if you look at growth of bacteria, for instance, okay, over time, or growth of population if there's no mitigating factors, is y will equal a times the e, which is the base of natural logarithms, 2.718. And I can do control 1 superscript bx. And we don't know what a and b are, but Excel can figure them out. And basically, if a curve gets steeper when you plot it, usually exponential growth best fits the curve, the data. Okay, so let's look at this in terms of Cisco annual revenues. And we'll see John Chambers, the current CEO of Cisco, in 1999, I think, made an error based on extrapolating exponential growth, and you have to be careful about this. If you're as old as me, you'll remember in 1999, when the internet was really thriving and the U.S. economy was thriving, we had the internet bubble. And it would go back and forth between Microsoft, Cisco, and I believe GE for who had the highest market cap. Okay, and for one day Cisco would have it, then Microsoft, etc. Okay, and the reason Cisco had such a high market cap is people were looking at the exponential growth of Cisco and extrapolating it. But the property of exponential growth, again, E is 2.718, something like that, the base of natural logarithms. And another way to think of E, if you take 1 plus 1 over n to the nth and let n approach infinity, a very large number, then that number will approach 2.718. If you've taken calculus, you know more about E. And basically, we can raise something e to a power by doing exp, you'll see in a couple of minutes. Okay, but the key thing about exponential growth, when x goes up by 1, y doesn't go up by the same amount, but y always increases by the same percentage. And that explains why exponential growth occurs a lot in the world. You think about targets for companies' growth, it's not in terms of absolute terms, in terms of percentage. Your company probably wants to grow 5% a year, 10% a year. And so that's why we see exponential growth. And why does the curve get steeper if you grow by the same percentage each year? Think of the U.S. population. If we had 1 million people in 1800 and we grew 10%, we grow by 100,000. Okay? But if we have 100 million people and we grow by 10%, we grow by 10 million. So you're growing off a bigger base, so basically the curve will grow more steeply. Exponential growth also describes the growth of capital when you earn compound interest. Okay, so let's look at the Cisco data. We have the years were 1990 through 1999. But if you want to fit exponential growth, you have to start with the first data point having x not be 1990, but x being 1. And then the sales would be y. So this is what we call a trend curve in growth of a product, okay? But if you start with 1990, you get like e to the 1990, which is too big a number. So when you fit exponential growth, don't use the actual year. Use, which in this case was 1990 through 1999, start with a 1. So if I graph this, should I fit a straight line? Okay, Okay, so let's take a look at that for Cisco. Okay, now if you look at this, if you wanted to fit a straight line, that means one of two things. You don't know what a straight line is, or your eyesight needs some work. You need to go see an optometrist for contacts or glasses. That curve is getting steeper. A straight line has the same slope everywhere. So basically, when a curve gets steeper, you should try and fit exponential growth, and then you can get the CAGR, or compound annual growth rate, by looking at the ratio of the prediction. When x goes up by 1, y always goes up by the same percentage. And if you subtract 1 from that, that will be your compound annual growth rate. So I go right-click in here, add trend line. Okay, so I'm going to fit exponential equation. The r squared here doesn't have as much meaning. It's a little technical. The r squared here is not the percentage of variation in y explained by x. It's really the percentage variation in log of y explained by x, which doesn't have that much meaning to us, so let's forget that. But we can see it's a pretty good fit. Let's see. So this is Cisco revenue. Okay. And let's make this a little bit bigger if I can. All right, so that looks good. All right. So the annual revenue of Cisco could be predicted by 58.553 times e to the 0.5694x, where x goes from 1 to 10 in our data set. Now you notice this is a really good data except for one thing. The last point falls way below the curve. Now, what does that tell you in real world when you're trying to look at sales of a new technology? Once you fall below exponential growth, you're probably never going to get back on that curve. And it's time to look for a new product that'll put you on an exponential growth path. A company that's mastered this is 3M. They have a rule, I think, maybe a third of their sales or half their sales should be from the last products developed the last 3 or 5 years, because those products will grow exponentially. Okay? And so basically, if you can keep coming up with a new product portfolio that is new products, you'll always be on this part of the curve, and you won't basically have your growth flatten out. Intel has done this by introducing new chips. The former CEO of Intel, Andy Grove, introduced the phrase ride the second curve. Microsoft went from being a PC company to an internet company to now being focused on mobile, because that's where the growth is. There will always be a new frontier of technology where the growth is. You want to be, as part of your strategy, as much as possible in the new technology. Okay, now let's put in this equation, get the prediction, and then we can get the CAGR. So the prediction would be 58.553. EXP is how you raise to a power, 0.694 times the year. Okay, and if I copy that down, you can see the predictions are pretty good, except in 1999, it was predicted 12 billion, 17 billion, and they only hit 12 billion, which is a big shortfall. And soon came the collapse of the internet bubble in the year 2000. Okay, and so you could have almost anticipated this. Now, John Chambers, I believe he said in 1999, in 5 or 6 years we'll be a $500 billion company. Where did that come from? Well, in 2005, that would be year 16, and the predicted sales would be 500 billion. Now, that was assuming the compound annual growth rate would continue. And what's the compound annual growth rate? Take next year's year 2 prediction divided by year 1 and copy it down. 76%. See, every year the predicted growth is the same. Remember, we said x goes up by 1, y increases by the same percentage. So the CAGR would be that 1.76 minus 1. Okay, now suppose I want to get the CAGR for Google in the years 2006 through 2010. Here are their revenues. Okay, so I can graph the Google. Let's see if I can move this. Let's just cut the Cisco. Put it over there. Okay. Now, if I want to get the CAGR for Google, I would look at these years 1 through 5 instead of 2006 through 2010. I would get the chart. Now, it almost looks like a straight line would fit this, but to get a CAGR, you have to look at percentages. Okay, so if I try and fit exponential growth here, go right click, add trend line, exponential, display equation. Now, make this a little bigger, control 1, let's say 16. Oops. 16. Okay. So if I put that equation in, so the predicted revenue equal 33.355 times e to the 0.3933 times the year number. And if I look at that ratio, that'll give me the CAGR. Looks like 48% for Google. So if I do Google CAGR, I would just take this minus 1. So it looks like the compound annual growth rate for Google was 48%. Now I don't have the data with me for 2011 through 2015, but probably Google was approaching what's called an inflection point, where the growth rate goes from getting steeper to flatter. It's called an S curve, and once you get past the inflection point of that S curve, it's hard to grow as fast. And if you're doing valuation models for companies, you really need to understand that. The people who valued Cisco in 1999 as the most valuable company in the world did not understand that 76% compound annual growth rate they didn't understand it wasn't going to continue forever. Because where does the growth come from? I mean, once you're in a huge company, where are you going to grow 76% a year if you're a $200, $300 billion company? It's really hard to get that kind of growth. Okay, that completes this video. In the next video, we'll start talking about another important part of the trend curve menu, which is the power curve, which is perhaps the most versatile. Because while a straight line always has the same slope and the exponential curve always gets steeper, the trend curve can get flatter or steeper. Okay, and it's usually used in model situations in which you graph the relationship between two variables and the curve gets flatter, as we'll see shortly.
Okay, so thanks for watching, and there's a free course, a free 21-day course from Dr. Winston, and all of these videos are coming from one of 3 books. So first, this one, which you can see here at the top of the screen, Microsoft's book, which has 355 reviews, and then it's, let's see, 4.6 stars. It's coming from this book as well, his marketing analytics book, which is down here, and you can sort of see 4.5, or his newest book, his analytic stories book, which is here. And with that one, you can see it's 4 point something, or maybe even 5. I don't think it's 5. Yeah, 4.8. And so, yeah, anyways, in the description, there's a free 21-day course from Dr. Winston, or you can go to excelwithwayne.com/free, and it'll be there. But again, thanks for watching, and if you have any questions, just please let us know. Thanks.